Okay, hello, welcome everyone. My name is Matti Heino. And, I'm part of a project in pandemic prevention, as well as working part-time as in a small behavioral science advisory group for the Prime Minister's Office of Finland. So first thing I'd like to draw your attention is to like what is it that we mean when we say that two things are dependent on each other? So often we intuitively sort of think that, oh, so well, that means that when one thing goes up, the other thing goes up also, and when one thing goes down, the other thing goes down too. But obviously, we have also situations where these things can be sort of anti-correlated. And to remember, just to remind everyone that correlation is a linear measure of dependency. So here we have a positive correlation, and here we have a negative correlation. But we can also have situations where there is no discernible correlation here. But the surprise in complexity comes that there are many things are connected through this nonlinear coupling relationship, where you actually can have a dependence relationship, so that this is actually one system. At one period of time, it shows this sort of behavior. At the next, it's like this, and then at the third period, it looks like this, even though the rules in the coupling remain completely identical. So what are these complex systems? Well, we can sort of think of many different systems that are complicated, that are very intricate and very advanced, so to say. And then we have these sort of more natural systems, ecosystems, cities, people, animals, which we call complex systems. And these more complicated systems, in this situation, you can usually, when you figure out how to do something once, you can know quite confidently that you can use the same thing somewhere else. And whereas in this case, it can differ quite drastically from one system to another based on its history and other intervening factors. So we have these large networks of components that self-organize without anyone telling them where to go and what actions to perform. And they adapt and learn from their environment, and the environment adapts and learns from their actions. So if you want to know about the intersection between health psychology and complexity science, which studies these complex systems, and there is this paper out from earlier this year. I will just draw your attention to a couple of features of complexity that are important in the current pandemic situation. First of these is the so-called fat tails. So here you have an example of thin tails. This is the normal distribution, and you have a lot of small events and not very few large events. And this is because the things that produce this system are independent from each other. So they sort of cancel each other out. Whereas if you have an interconnected system, you can have this sort of cascades where one thing causes another, which causes another, and then you have a domino effect, which can lead to very severe extremes, which are not not something that you can just remove from the data, because they are actually part of the data generation process itself. And this is important because many complexity scientists tried to direct our attention to this issue in the beginning of the pandemic, and They also did this study of like historical pandemics, where we can see that the risk from pandemics is very, very fat-tailed. And when I took these the parameters from the historical pandemics presented in this paper, and I simulated 100 observations from that distribution, this is what it looked like. So this doesn't look too normal. You have many, many small cases, but then you have few bigger ones. And actually, I noticed that there is a 1% chance of a pandemic killing over 1 billion people. So one of these draws is actually 1.4 billion here. And this is something that was already outlined in a paper that came out in 2006, such that if no actions are taken, we end up in a situation where there is some novel pathogen which will go extinct at the same time as humans do. But luckily, there is also these complex systems. They also have some good features, so to say. We can have these mitigation behaviors such that the societal change, for example, can be nonlinear. Is the self-reported development of self-reported mask use in Finland, for example. But in just a couple of months, boom, it exploded. And these behavioral solutions and their effects are, of course, part of the work of the BESI network. In our work, we've been sort of expected, in the government, we've been sort of expected to mostly work with communicating the need for restrictions so that people comply optimally, and take the pandemic strategy chosen by the government and help in implementation of that. So we've been mostly figuring out, okay, so how do we communicate best to make people comply with these, mostly these behaviors? The problem, of course, is that if we have a situation of never-ending novel variants and waning vaccine efficacy and so forth, communication will be of practically no use, because people will sooner or later deplete their personal resources, and even more drastic reinvigorating is needed. Whereas we have some strategies where which don't happen on the scale of communication alone, but which actually mitigate the need to fight pandemic fatigue. So it doesn't take that much effort to put on to avoid going to a cancelled event, for example, a potential super spreader event. And there is a huge literature on, for example, the elimination and segmentation strategy, which is very attractive from a motivational and a behavioral science perspective, but it hasn't been really even discussed in our government. And I think this is a very big gap in the knowledge translation from one fields, from across different fields into practice. And if you're interested in that, maybe consider checking out this paper. Yeah, just to quickly conclude, we have the risk of fat-tailed events. We have the risk of waning motivation, waning immunity from vaccines, and we need behavioral responses. And we can do them, and we know there is the theory is there, and the practical examples from different countries are there. So in the work of government advisory, I think we should be more directed as a community towards not only implementing government policy via communication, but also taking up and informing the government policy from complexity science and health psychology, and from the intersection of these two about policy choices that minimize the risk from arising from pandemic fatigue. So thank you very much, and until next time.